lime is part of a major lime producer with the name is Carmeuse. To give you an idea on the who is Carmeuse, Carmeuse is a Belgian family-owned company, okay, and on a worldwide scale we are number 2, okay. You see there on the screen the yellow countries are the countries where we will have facilities like Golden Lime here, and that means that in that local markets, as lime is mainly a local business, we supply the local market and we have, let's say, a lot of interactions with the local communities. It can be, let's say, depending on the application, but for civil engineering, of course, and railway and highway construction or road construction, of course, we know all those departments of highways and railways very pretty good, and also those research centers and universities. So what I will try here to explain is in a snapshot what we know already today based on this new, let's say quite recent, not new, but let's say more recent methodology and the projects that we have. So it gives you here family-owned business. I said a turnover billion of 2 billion euros. Gives an idea. So we have 59 factories all over the place, 55 are quarries and mines that we call. And the yellow countries are the ones that we have the facilities, and the blue ones or the green ones are the ones that we supply a lot. To be honest, we did a big acquisition here, so this should be now already also in yellow. That was only some weeks ago. So what is the mining industry doing for those on resources? And that will be so we are always stripping first of all the let's say the topsoil to remove the let's say the good limestone, because we are always looking to very pure calcium carbonate. Okay, so we need pure calcium carbonate, and that is a bit not scarce in the world, but at least each region has a bit of a, let's say, their good calcium carbonate regions. Of course, because once it is too low, and too low means below 95%, we are not more interested. It's a very good stone for aggregates, for concrete and asphalt, but not for us. So we drill, we blast, we hole, we do the crushing and the screening, of course, and then comes, that is typically for the lime production and calcination process, in which we will produce quicklime. The product I will speak about you will always be, when I speak about lime, it is quicklime or calcium oxide. So it is not hydrated lime. Okay, so honestly, we have to use calcium oxide or quicklime in earthworks. So for some other applications, we have also in hydration. So you hydrate it, so that is called calcium hydroxide. And then, of course, we have the expedition and end of life. We try to reclaim, let's say, the quarry and to bring it in a natural status where there is a bit of more biodiversity. So with birds and something like that, because we discovered due to this a lot of, let's say, green initiatives that when let's say a mine is stopped, there is new way of, let's say, of this biodiversity of insects and animals, mainly birds and this kind of thing. So when we speak about the lime business, so we are looking a bit like a cement factory, okay? So we have a bit the same. You have a quarry, you have a kind of kiln system, and then you produce not clinker but calcium oxide. So, but where are the products going to? First of all, it is steel or iron and steel. And then I will speak to you about the second most important market, which is for us the civil engineering. So out of civil engineering, that means road construction and asphalt, okay, but mainly it is earthworks. In other applications, you see then another one, also in construction, it is building materials. Think about your aerated autoclaved concrete blocks. So lightweight blocks to build, you know, the high-rise buildings you have in your country. So those are really an important market for us. And this part is presenting, let's say, a big piece of the cake. So construction is 26%. But we are also in other initiatives, for example, in flue gas cleaning, so to clean, to remove the sulfate or the sulfur from the flue gases. And we are in purification processes, mainly in non-ferrous. Think about the mines for nickel, copper, lithium, you can name it, and gold mines. They are all customers for quicklime. And also a lot of use is done in the chemical industry, always a pH corrected, okay? Because lime is something that creates easy, let's say, a stable pH in the process. But at the end of the life, let's say when we throw the water away and let's say from the sewage pipes or what else, there is wastewater, let's say, treatment, and also for that we are trying to purify it because quicklime is extremely reactive. Also there we create something, then kind of a sludge, of course, in which lime, let's say, captured most of the pollutants, and then to cultivate, for agriculture, also that lime is bringing calcium to the soil, increasing the pH, and due to the increased pH, because mostly due to the rains, it is more acidic soils, or a bit too acidic soils. So due to this increase, the fertilizer will work much better, and the farmers have a much more higher efficiency because fertilizers are very expensive. So, and then yes, paper industry also important in this area, for example, and then also in the past. Those are the main applications for typically, let's say, our business. How does it look like? You speak about the limestone. When it goes to a lime kiln, it looks like this, and when it comes out of the kiln, it has the same size, and the color has changed. I will explain what is happening. So, if you speak about, let's say, the limestone, okay, we are going to increase the temperature stepwise till roughly 1000 degrees, a bit higher, and you see then the stone is starting to become white, okay, stepwise, and what is happening? So you see there, the calcium carbonate is removing the CO2, which goes to the air, okay, and then we have calcium oxide. In that process, if we see our CO2 footprint, 75% is coming from the CO2 that comes out of the stone, okay? 25% comes from the real combustion. So we have a high footprint, like in the cement industry, but like in the cement industry, it comes due to the fact that we have a very pure limestone, and that is very difficult to anticipate on. So, but you see, stepwise the stone, due to the higher temperatures, going to become more whiter and whiter and whiter, and at the end of the story, and because in a kiln, the process of the stone takes 24 hours. 24 hours. Okay. And then at the end you have quicklime. Okay? And from that one, that is the product that we will speak here with you for this training. So we have facilities, as I said to you, and also by the professor. So those are the factories in which we have, let's say, facilities. This is the European map, so I'm living close to Christoph Lister in Brussels, so that's me. Okay, just a joke. So, and this is our footprint in America. So we are really on the east side of the United States, and those are also the main steel industry. So it's far away the largest. So in North America, we are far away number one. Okay, as a producer, and because a little bit all the car companies, let's say, and the old steel industry and the most requiring industries are on that side. On the western coast, you will find companies like Google and so on, okay, but they don't need lime or not that much lime, okay? And those are, let's say, the numbers and the factories we have in the area of North America. And then to visualize the map, so in Africa we are also number one. We are focused with terminals because lime production was so many years ago very difficult in that area. It's also a complex process, corruption and political situations, and you can name it, and roads in a very bad condition. So most of the lime was, let's say, by terminals imported, and this is an area with a lot of mines, gold mines, and yeah, due to that there's high lime demand, and also South Africa. By coincidence, there we have. Because here we bought also end of last year, also one of the local players, but we were already present with a joint venture with another player, and we from here we supply really this southern part of Africa, where also again we will find access to the mines from copper, copper and gold. I think also nickel, but very honest, it's not my area. So my area is only, let's say, Europe, Middle East and Asia. And when you speak with Middle East and Europe, you have seen already. And Middle East and Asia is in the developing world. Here you see that we have a facility close to, not close to, but in Oman, on the seaside, where we are, this is becoming now today our biggest factory, and they are shipping quite a lot towards India, where we have several terminals in the most important, let's say, facilities already. And here you see them on the right side, that is then Thailand, where we have 3 factories or locations where we do develop our business. Offices are in Bangkok. So, if you want to see a look about how golden lime looks in that area, And what's the name from the village, this area, this city here, Adisak?
Salabri.
Salabri, yeah,
Yeah.
but it was another name, CS or something like that.
Yeah, Sham Salika.
Yeah. But this is Salaburi, okay, very next to the cement factories, and that is a factory, and you see kilns there, already 5 or 6 kilns here on the map. So the stone is always coming from the beginning, it is moved up to the top, and then in 24 hours it's going down and down and down and down, and here you have the, let's say, the hottest part of the burners, let's say, it's at that level, and then it's cooling down, and then it can be, let's say, then you have carbon monoxide, and then it can be hydrated, or it can go to the steel industry. We are a chemical industry. This is a little lab in the factory that was mentioned about Saraburi area. But we are not coming here to present, the company and that stuff. I'm here to explain some basic principles for earthworks. And earthworks are a quite important topic and a very expensive, let's say, on cost side, for agencies, for highways and railways. And they are looking for solutions. How can I build my railway 200 kilometer stretch in just only 4 years? Then you come to a solution, but at speed, 160 or 360, right? How do you do that? That's maybe not in 2 years, but sometimes in 5 or 6 years, but still it is a massive amount of materials. Then we will speak about earthwork projects in millions of cubic meters, 10 million, 20, 30, 40, 50, 60, 70. Today, the biggest project we are involved is 70 million cubic meters to be done in a spread period of roughly 4 years. So it's massive amount of materials to make it. And with this application, we will try to show you that it is as good as an aggregate. As good, even better. Even better. So I will speak here about soil treatment for earthworks. So that is the part, how do we design the case studies of Europe. I did a focus on railways, as railways are quite already, let's say, for high-speed railway and so on, or for conventional railways, people are thinking more twice compared to a road, because their risks are a bit slightly. And I want also to present you my code, or let's say not my code, sorry, the code of good practice, together worked out with, okay, the lime industry, that means the European lime industry, where I have also a function, and also the Belgian Road Research Center, where we work together, let's say, to work out based on the European experience. Case studies and code of good practice also giving a lot of information on what I will explain in a short time. And then I will go to the conclusions, let's say, what I wanted you to show you in this presentation. So, what means soil treatment for earthworks? So, first of all, when you are in big projects, and so, and what I mentioned, highways, railways, or roads in general, or even industrial building sites, where we do, we're building car factories, you see areas of 400, 500 hectares. Okay, so typically it's very sizable areas where, let's say, people are looking, okay, there is a traditional solution which is we call aggregates, and you have everybody in the world has local aggregates, and there is soil treatment as an option where we will recycle the local soil. So we speak about the local soil, okay, in place. So what we do is we will mix that soil by lime, which is we call the brand name ViaCaCO, because we have some limes, but also hydraulic limes. It means also limes with a bit of hydraulic specifications, but as sometimes soils are very, let's say, vacation, but also our product we will adopt the right product for the right soil, that we can use quantities, let's say the lowest quantities for that solution. Lowest quantity is also lowest cost for the agencies. So, what's always the big challenge when you use aggregates, or let's say this is how it goes today. So you have a landscaping, you want to make, let's say, a kind of, let's say, a stretch, or let's say horizontal, let's say a roads or a platform for the railways. So you see a kind of, let's say, overburden already, and then what you do is, and that we see is people are going to remove what we call the bed soils. They are too plastic, okay, plastic index is too high. And unfortunately, you need always a lot of trucks to make it happen. Trucks, CO2, and cost. Okay? And then you come into the situation, yes, okay, now I get to go to a quarry. to buy my aggregates. When you buy your aggregates, which has a cost, and on top of that, you have to fill now to get, let's say, because to get that smooth platform here for your railway or highway, yes, it has to be filled with good material. This is what we call the traditional method. And this method creates two things for me. Costs, lens filling here, which is also a cost, and visual, I would say, deterioration of the landscaping, of the original landscaping, because in case you have millions of cubic meters to do, fairly honest, you have to look for probably better solutions. And the quarry, let's say the aggregate itself, has also a cost. So it's a lot of cost that you see, and at the end you have waste. What we do, we say, you have the same landscaping, you have one, like to make the platform for your rail or highway, you have one truck of the binder that is lying, and you use, let's say, the methodology of soil treatment that I will explain you. It is officially called shallow foundations. That's the name, okay? So we are not in the deep foundation, but in the shallow foundations. And when you go for that, let's say, application, okay, you have to ship the soil from that area to that area. That's true. So you need trucks as well. It's fairly honest, I do. But you reduce the number of trucks shipments from 60 to 80% on an average base. That's all. It's sometimes some kilometers to ship it, but that is it. So what you see is no landfilling, no waste, only one product to buy, one truck, and not massive amount of trucks. And this is, let's say, the trucks for transportation that you need to use. So in the method in place, this is, let's say, the method that is used by, typically, you see, for example, a new road, so you're on the soil in place, so there is a spreading of the line or the binder, then you have the soil mixing of the line, that is a special machine dedicated doing it, and then at the end you have typically compaction and the graders to make it and to finish it, like in every project. So this is the two machines that you really need to have, good machines to make it on a good way. Because when we speak about soil mixing of lime or spreading of the lime, when we say, okay, it needs to be 1%, it should be good, let's say, that the machine will put 1% and not 2%. Otherwise, the contractor will lose a lot of money because he needs to pay the lime. So he has all the interest to have a good machine on the spreading and the soil mixers. By coincidence, all those machines are available in Thailand here. Why? Because they are already used for asphalt reclamation. And asphalt, you use a lot in some areas, every 2-3 years, you recycle your asphalt roads because the top layers are, let's say, fortunately, in bad condition due to floodings and what it might be. And those are the same machines. And those, fairly much, you have everywhere in the world. Right? So that is easy. And how does it go? You see, typically, let's say the process. So from a lime spreader, so that is, okay, it's a German brand, but they have also already, let's say, a factory in China, but they're spreading, let's say, the right quantity. The company, in this case, is a Whitney company, and you see then a kind of a layer. And this layer that they treat with this machine can go from, I would say, 30 to maximum 50 centimeters, but I recommend 40 as a maximum, because when you have to make your compaction later on, and this is the sheep food compactor, when you have 50 centimeters and to compact, you need a lot of energy, okay? Especially when it is cohesive soils. In case you have sand or a sandy stony material, it's easier. But for this type of material, when it is cohesive materials, we like to have the sheep food compacted, and then afterwards you compact it by the normal compactor, which is here, and this is then the way to finish it, to make it smooth. And you have a very good smooth surface. You can do 30 to 40 centimeter on a good way, with all the tools you have. And in case the landscaping was, remember, the first landscaping can go sometimes down, and sometimes we face 20 meters of filling, so 20 meters all the time. Okay. It can go up to 20. I will show you a showcase from Belgium with 18 meters, but I went into projects let's say my largest project that I was personally involved was 37 meters. Fortunately, it was like in the very, let's say, steep valley area in which, let's say, they had to fill 37 meters to make something, let's say, horizontal. Now, how do you design then the earthworks in your project? Because at the end, that is your engineering properties. So Here I give you an example how typically I would say European project is done for railways. Okay, for highways, it's a bit the same. So we have then what we call this is an high-speed railway, for example. So okay, in Belgium and France they use for speed. That's a speed to 350 km/h. Okay, so then they have something like 70 centimeter of ballast, which is traditional, but you see also. And then below that there is also 70 centimeter of aggregates, 032 and 080. And so those are two layers. And that is what they call, let's say, the platform base. And everything below, we will call it, let's say, the earthworks that has to be done. When we transfer it to a road, this would be the asphalt, let's say, the top layer. And then here we have then the base. Okay, and this is what we call then the sub-base. We will call you later on that terminology which is used here. So, on the platform base, when you have an existing landscaping, okay, you place somewhere your platform base to make it, oops, it's a bit not easy when you are outside, but you see, you go up on a horizontal way and you would like to get that the soil you will excavate will fill the part which is below. So we will pull one of the parts, so that was for a platform and to be built. So the existing landscaping, here we'd like to reach. And there you go for the filling zone, so that will be the one that was below. And this is then the excavation zone, where you take out of the soil. Then, typically, yes, remember the truck transportation, so you have to ship, let's say, from one area to the other, in which you recycle everything, so that you don't create any waste, and that you really have, let's say, optimized your project. Here is the names of the different layers which we use in earthworks, and always we go till 1 meter below the platform to be stabilized. In case of high-speed rail, it can be less for a highway. But everything will depend. Now, we spoke about soils. It looks easy, but okay, which type of soils do we speak about? So here you see then the first analysis that we need to perform is the soil classification. This table gives you, based on the American AASHTO standard, so the soil classification, and we are really working in the fair to poor rated soils. The poorer you are, the better we can help you. So, which are so we speak about A2 soils, A4, 5, 6, and 7. And what we are looking to is always, we need a plasticity index more than 5. Okay? When it is more than 10, we react more. When it is more than 15, it will even much more better. When it is more than 25 or 30, and you can name it, we are in the game. What we look to is, let's say, the plasticity index. Okay, organic materials. If it is too much, then we will have also an issue because the organics will eat the calcium. So then that's an overdosing and so on. So then you have a bit of special treatment. So it still can be more than 5, but very honest, it will be overdosing by the quicklime. And then we look always to the sulfate or sulfate content in the soil on a natural way, because due to some natural issues, you can have natural sources of gypsum layers in your soil. And gypsum, when you mix it with water and a lime, it creates gypsum, which is called an intrinsic, in which you have expansion reactions. And okay, in agricultural areas, because farmers are putting a lot of nitrates and phosphates, to cultivate faster and more efficient. Yes, there we look also to see that not too much, because again, you need overdosing of lime in that case. But that is it. Okay, it's a quite simple test, and we will make them on a visual way. So, what is quicklime or calcium oxide doing when we put in the soil? So the brown element is clay, just clay, and the blue is water. Okay, and it will react immediately exothermic with the water to create calcium hydroxide. And so then you have a bit of calories here, and it starts to flocculate. Flocculation is typically the process when you go from this clay and you mix it, and immediately it becomes granular, like a stone. It's easy to manage. This is difficult to manage, and so when you see it in a mixing unit, but not easy. But this is really easy to manage, and that means for a contractor, easy to work with. And then, due to the flocculation, so you increase the pH, and to know how many lime we need to put, we speak about the pH test or the lime fixation point. It's in the United States standard, the EAD is green test. So we are looking to something more than 12.4. Why do we need more than 12.4? You are looking to in the next phase to get the puzzolanic reactions. And the puzzolanic reaction can only happen with elements of silica and alumina which comes from the soil, from the clay. Okay? And you do this test, a very simple test. So those tests are are not performed in typically, let's say, the geolabs, but 1 or 1.5, 2, and so on percentage, let's say, to make it easy. After that, then you have this higher pH, so long-term modification due to the pozzolanic reactions. This is the calcium silicate hydrates that you are formed in the process, as well as the calcium aluminate hydrates. While the silica is coming from the silica which is solubilized due to the high pH, and the alumina is the same. So in these conditions, let's say we will go to limited swelling. I say here below 1%, sometimes in countries it's below 2, 3, 4%. It depends a bit where is the earthworks or the filling material to be placed. So, okay, and it keeps the cohesion even in water, because here you see the cohesion. So, for example, soil treated with lime, and it is just, if I remember, was 2 or 3, let's say 2%. It looks like a concrete stone or concrete tubular. Okay, the same soil without the lime was this one. So, due to let's say the fact that you have the lime in the soil, you have many, let's say, better mechanical performance, which I will show you. But even before speaking about mechanical performances, there is another aspect which is extremely important for the contractors and the easiness to work on a building site. We all know the Proctor compaction test. Okay. So you go for an optimal density all the time, and normally you have to work within this 95 optimum contract area. Okay. In the case of a natural soil, you have the kind of blue line. Okay. So, and then what happens is, let's say, if you have this blue line, and 95% you can only work in a very small amount of area of moisture content in the soil. Not easy. The fact that you put 1, 2, 3, 4 or some, okay, you are flattening the curve, and you see that you can work in a much more larger area, so that for the contractor, it is in the raining period or in the dry period, he don't care anymore. He can work all the time. And that is one of the main advantages on the building contractors, let's say, to make it happen. If you speak about compressive strength for projects, let's say, linked to earthworks, this is a kind of a classification, but every country is in Europe a bit different, but it gives already an idea. So on the UCI, because that's compressive strength, so we can, depending where you are in the layers, 0.2 megapascal, 0.5, or 1, sometimes even more. It depends, because for some soils, we want them to resist to freeze thaw. In that case, we are even looking to 2.5. That's the highest we can reach. But in those amounts, or those type of projects that are very, very limited. So to be honest, I don't see freeze thaw from here. Not in this area, at least. But you can say, okay, maybe in Chiang Mai or in mountain areas, I would say maybe yes, in that area. It could be that there is certain, let's say, freeze thaw cycles, but to be honest, we have to speak about the freeze thaw cycle for a material that is earthwork, which is 1 meter below ground level. Not that many areas have freeze thaw. Okay, but that is typically, let's say, the values you might expect in which we are going to participate. And if you remember, and also another test is CBR features. We all know that CBR 100 means it's a fantastic aggregate. Okay? And in most of countries, it's very difficult to find aggregate which is 100. Most of them, they will be around 70. To do a test that we recommend always to do, and to have a good idea on the real value that you will have, do the test on the CBR features, let's say to measure it, but store them 7 days in the air, like you do. You put them 4 days soaking in the water, not 2 hours, 4 days, and then you will see if there is swelling or not. And at that moment, you measure the swelling which is linked to the sulfate content. in case you have sulfate in your soil, sulfate sources, it will start to swell up. Okay? So, but what we notice is, fairly honest, yeah, 10 to 100 is, yeah, the most of the time you are 60, 70 already after 11 days. And it will continue to grow, because after 28 days, it will even be higher. So, you can have values of 150, okay? So it's really feasible by just traditional soils. Coming we look now to Thailand. If we look now to Thailand, you have also, let's say, the main map of the forms of Thailand. So that's a map that I could take from somebody, let's say, that takes it. So that's the claim. And we are now, let's say, already starting a bit to look in this area about the soils. Why? Because our factory is here. So in that area, it's normal. And then you have also the right soils for that, let's say, application. Today, I will be honest with you, we did not yet, as called the line company, looked into the ViaCaCO soft place. Although I know it would be also positive, very positive. I expect, I expect positive items. But until now, we only started, let's say, roughly 1 year ago to work now in this area to see a way to identify all those opportunities. So, if you look now to Thailand, okay, you see the areas we are living, that we are, let's say, working on, and you see there already on the screen the road construction where we say standard for base course. The base course is just below, let's say, the asphalt layers, and then we have the sub-base. I'm telling you, it could be feasible at higher dosage to work to be present in the base course, but I would like to push my focus more on the sub-base course, okay, in which you have, let's say, much more need for good stability, especially for rails, highways, or in many areas. And this is the main use worldwide of our products. So it's always 1, 2, 3% mixed with the soil, but here it is mainly used for. It's for railways, I explained already to you, and this is for highways, to the Thai highway specification. So we can here compare, because you have something similar. Soil cement sub-base. There is a department of highway, kind of, let's say, a rule and a standardization mode, which we know, and then they speak for this, let's say, layer, you have values of more than 0.7, 0.69 megapascal, while here you need already 1.7 megapascal after 7 days. I will show you afterwards some values that we just reached, that we can reach in those, let's say, 7 days period. If you look a bit more deeper to the subgrade courses and materials, so you have selected materials what we call A, B, and soil fill and sand fill. So we try to be in line, equivalent to that material, or those materials. Okay, so it has to be at least as good. That's what we are about targeting. So let's look a bit to CVR. When we look for example, let's say the maximum that I see here, the CVR more than 10, and swelling depending on is more than or less than 4%. Values which I presume are easy to reach when we test also with local soils already. Just a message. We can show you a lot of soils, but what is happening if your plasticity index of the soil is only 30, let's say is 33, so it's a bit higher. You put 1, 2, 3, 4, 5% of, let's say, what we call a stabilizer, but okay, it's cement or lime. You just compare lime and cement. What is happening? So if you have 1% of cement in a mixture with soil, you reached after 7 days, according to the Thai way of working, with 2 hours of water in the water and soaked in the water, you have with cement 0. That means 0. And you see how the soil with the cement is, let's say, reacting, and then you see already 1.5 after 7 days. So that is not nice. 20 days, 60 days, it will even go much higher. But you see what is happening. So with cement, you need much more materials in order to get you in the specifications to be sure that you are there. Here we are sure we are always there. Okay? It's the magic of quicklime that is really transforming at a very low cost the material to what it is now. So, how do you prove that we are trying to give you that it is a sustainable approach and very proven? Because a bit going back to this development, why is it not yet here? This one of the soil mixing machines in 1995 47, so remember it was the Second World War, and I'm European, so in the European countries they started to develop themselves with the new roads because everything was bombed and so on, and those were the first, let's say, they tried to make soil mixers, and this is what it looked like at that time. Now, in 20 years later, there were already some, let's say, tools. This is a, let's say, machine from the construction, like a machine that pushes, let's say, the aggregates. While here you see then like a plug system in which they were trying to put, let's say, mix the quick lime in the soil, but not easy to do. Okay? And in 1980 there was an American company, the name is Caterpillar, very famous as well. They developed, let's say, the first soil mixer, which was really now in the beginning and a very robust machine. They sold quite a lot. But once we came to European, let's say, roads and railways, high-speed railways, okay, the Caterpillar was maybe a bit far away, and the Germans, let's say, took a bit the lead with those companies developing, let's say, better and better tools for the soil treatment market. Those two, let's say, suppliers, that is a Bomac and it is a Wirken company, are located in Germany, even very close to each other, only 100 kilometers, and they are, this is already number 1, and this is the number 2 in the world of soil mixing machines. Maybe somebody in China coming up. Well, due to the fact that the machines are developed, you can do the job. That means that more and more people are interested. And what you see is, you see a map where some of the, I explain you the map of some universities that are really knowledgeable and that help also to make that book. Okay, so on the soil treatment, so the full story, based on massive amount, of course, of studies. You can name it in PhD or national research consortia, or you, with the road agencies, with the railway agencies, you can name it. So those are, let's say, typically I spoke about machinery providers. Bomac and Wirken, they are located there. I was living close to the Belgian Road Researcher, which is the number 9. So it's a National Road Researcher, which is then, okay, you are a Belgian company. But in the line business, the Belgian line producers are, let's say, are the leading companies worldwide. And we have them in France, Spain, and let's say more in the western part, where the high-speed railway took place. Okay, and due to this high-speed railway, there was massive amount of people looking into it to make sure that we don't make any mistakes. So it resulted now in many national books, but this is the last edition, and it overviews a bit all of Europe. But all of Europe can be very interesting to do as well. And so, because all the experience we do is for highways, industries, railways, and now we are working on waterways and dikes, but this is the part I don't want to speak today because that's a very specific part. So the railways are the most complex, I would say, compared for those three. If it fits for railways, it fits for us. So, okay, and it's always the same principle. We don't change anything. So on the building side, as you have already seen, which are the typical machines you need to have. For you have the lime spreader, you have the soil mixers, and those are the preparation machines. And sometimes they are putting also, or they're adding water to the soil when when the soil is let's say not wet enough, especially on the surface, because you mix always the last final 30 centimeters. And when we have very dry conditions, water can dry out on a faster way compared to the moisture which is a bit inside. Always the 10 steps. You go to a site investigation. That means you take the soils in the beginning, you test them, you see what you have. Okay, by the delivery and storage is on the site. You prepare, you do this lime, you spread the lime, you mix in the site. There is a mellowing period. That means when the soil is mixed with the lime, it's always good to leave it 2 hours of mellowing. 2 hours of mellowing it before the compaction. So, okay. And then it's compaction, grading, but that is the protection of the works. Eventually, when it is very dry and the last layer need to stay in there for several weeks, okay, then you need to protect it by curing it, and then controls on execution. But controls on execution are exactly the same as you do already today. I don't want to put you on new, let's say, test methods. No, you use the ones. Here is, for example, typically tests that we can easily compare countries. If you do the static plate loading test, That's one of the best I can recommend, because then it's easy to compare yourself with other ones. Some are using dynamic, let's say, measurements like Beckelman test, or you can name it. Then you are country-wise known, but not in the rest of the world. This is for the density to measure the moisture content, and this is just weighing, let's say, the kind of the lime quantity on a certain surface, so to make sure that you have the right quantity in the soil. A lot of tests are described on a simple way in the manual. So, where did we build, for example, and it comes always, this is the European network of railways. And you will see on the street, this is the high speed, what we call then the operating speed. Because when you speak about operating speed, the line is developed to 50 kilometers more. Okay, so then normally the official tests are done with a bit more, but you see then typically the most, you see a lot of red lines that is too close to 300 kilometers per hour. Let's say the purple ones are more, let's say rare. The orange are quite a lot as well, and then you see the lines also to the yellow lines. And if you have other lines, then it is lower than 200. Sometimes, let's say, I would say 160. So, okay. I will show you, let's say, very snapshot the 5 areas where, due to all those projects, because you need massive amount. Right? Think about the country. We are now here working. Let's say the project here, United Kingdom, is. Yes, at this moment it's 70 million cubic meters. Okay, this one, they need it in just a couple of years to be done. And here I have, from my younger period, a lot of experience from that part. France was slightly before my time, but here in Italy, we are also the #1 producer of lime in Italy, with all factories all over the country. So we are also supplying lime, and this is the last one of the last lines. We have Napoli to Bari. I will explain you that one. And this is an interesting story where we increase more and more in Central Europe, where due to, let's say, some time ago, it was communist times in that area. There was, since 1990, there was a fall of the wall in Berlin. Okay, so Europe became united. But we saw in the communist areas that nobody invested in railways anymore over the last 20 years, so there was no investment done since 1970. Today they are still running on the same maintenance. Okay? And now the trains, they are doing 60 per hour. Then you start to get problems, because that is not more acceptable. But investing in railways is expensive. I will try to show how you can make it, let's say, the speed. And this will become the fastest train in Europe. So, to come, France was the first one. They started because the idea of high-speed railway came from Japan, by the way, so it came from Asia. And they wanted to have, let's say, the line operated between what we call Paris and one of their major cities, which is Lyon. It is on the road to Marseille, which is the second largest city. So Paris-Lyon was finished in it's a stretch of 570 kilometers. Okay, so it was the first line. It was opened in '83. I think it started the real beginning. It was the beginning of the '60s. So after the Olympic Games of Tokyo 1960, it must have been 65. Okay, give it 20 years. But in 20 years, at that time, they could already realize with not the best machines. Okay, the line, and it was the first step. And stepwise, they did it to other lines and so on. Okay, how many quantities was used? We speak about more than 100 million cubic meters we treated. Okay, always saving a lot of aggregates, massive amounts of aggregates. So, you have then, that's the line where I am living close to. That's the line from Brussels. Brussels is here. And then you go to the first, one of the major cities in France, that is, the name is Lille. And myself, I'm living very close to that line. Okay, 30 kilometers out of Brussels, but only 1 kilometer from the high-speed railway line. So where the speed, that's really in my area, where the speed is 300 already. Okay? And those were pictures from that side at that time. And how much did we do? I think it was 20 million cubic meters, 20 million. And we built 300 kilometers of new built high-speed railway sections. We have done a little bit of tests, and I can show you some tests because there were publications. It's easy for me then to get access to those publications of those times. And this is example, there was an existing, let's say, highway already, and they wanted to build a high-speed railway next to the existing one. What do you do then? So that was the test section, or that was about Macau. It's close to a city which is Liège, between Liège and the German border. So it gives you an idea. So what is the very simplified model of the problem? You see here the highway was nice, and then you put now the railway, okay? And you are something like 18 meters to be filled up with a local road which was there, so it has to be, let's say, placed also on an existing embankment which was in that format. And what they did is they made the local soil always available from the area, and yeah, the local road we moved now to that part. And on top it was built then with this high-speed railway, let's say, project. So what they did to test it at the time, because they were also uncertain will it last. Okay, they put a kind of a test embankment on the full system, and with surcharge at that time, because the train was not yet there. So they simulated, let's say, the most important, the simulated dynamic loads of the train that could happen, and then they were measuring by borings till 25 meter depth and 20 meter depthness here. So the full system, how it was, let's say, reacting compared to them there was not, let's say, really important elements. And when they discovered that when you speak about treated soils on an existing embankment, because the highway was already also built with like treated soils. Okay? So when they understood it, then they said, that's good value, because for our projects that we can take into account in the design that the internal picture range is roughly always 30. It's always value that you will find between 30 to 40. Always something those values. And the cohesion is roughly 31 or 30, okay, that you will find back again for such kind of layers. And they said, due to those values, we can now start, we need to be sure, more sure, compared to let's say, to the topics that we want to achieve, let's say, for the stabilized roads and the stabilized embankments. Now, going back or coming back to another country, not coming back, but going further to another country. Now we are in Italy. You see here Milano, you see here Roma. So this is the most important city economically in Italy. And then Roma is the capital. So the idea was to build a high-speed railway between Milano and Rome as soon as possible. So that process started also in the 90s or end of the 80s. And unfortunately, Roma and Italy is located more and more located in an earthquake-sensitive zone. You see there the areas where you have much more, let's say, browner or darker surface, the more and more you have sensitive areas. So what happened, unfortunately, on that line, there was an earthquake of 6.4 here, yes, in 2016. A lot of damage, and they inspected the line, this line as well. And fairly honest, there was no problem on the embankment for that high-speed railway. This was orange, so that's a train between 250 and 300. So, or a bit below, I think 250 on that part. But anyhow, it has proven track with the Italian, let's say, it was fair, and they are working, operating, let's say, doing design for railways all over the world. Today they are building on the same principle, let's say, they are railways all over the world. So again, yeah, we are now more or less close to 100, I think, for Italy only alone in high-speed railway. This gives you a bit of history about Italy. I don't want to present it. You will all receive the PowerPoint later on. So for those who are here, you will receive it, you can use it, you have the data, you can have to reflect later on. So if you take notes. So that it gives a bit of history, but I'm not sure that this is, let's say, the most important of this one. But this is the more important slide. Where do you use, let's say, the line? This was the brass line. You use it, again, remember the Belgian, let's say, drawing. This is the Italian one. You have, again, the ballast layers, which is roughly, I think, also 70 centimeters, or close to that one. And here you have, let's say, stone layers from 12, 30, and 2 times 30, also 72. So in total is 1.4 meter of aggregates, and everything below that is variable height is manageable by salt-treated with lime, simulating, let's say, the aggregates. And always put, let's say, a drainage layer below to avoid that the moisture can come in and create the pressure. between the layers. And you have to make sure that there is drainage, that it will not be attacked continuously by the water in the soil. The Hungarian case is a nice case. We go now to another country. In Hungary, Central Europe country, old, let's say very old systems of railways. Speed was only 60 to 80, so not good. So what they do is they have done most of the time they were, let's say, successful by building the dual lines between the cities, and they are removed everything. Now they are, let's say, moving the embankments by soil treated with lime. So here you see then how it looks like. So the train, one lane, let's say one line can remain open, so it makes it always feasible to, let's say, not to stop, you know, the interconnection between the two cities. So that is the positive point, although the frequency will be lower, of course. But anyhow, the lines can remain open, and in the meantime, they can store one side of the road, let's say, of the lane, one lane and one track, and then they do this other tracks. Also there, we do quite a lot on this kind of, let's say, upscaling the old lines to 160 km/h. It's always the same, and the principle is very simple. Because when you see here on the design, so this is, let's say, how it looks like. Again, you see then the railway structure with on top the aggregates, and here is one or two layers. I think this was, I don't remember how many centimeters. I don't read it from here. So I think it was 40 centimeters. I think this is 40 centimeters. Again, it's replying. So replying here, replying. Okay, it's 40 centimeters. It's not very readable, but this is, let's say, a thickness of one layer. Sometimes they did also two layers. So, but with that structure, they could build, you know, the top layers on the upper layers on a better way, so that they could reach the speed of 160 on the existing lines. Now, in the Hungarian experience, has learned a bit issues. So there are typically issues that can happen. So they have also a bit of, let's say, landslides in some areas. They have, let's say, the problems that are typically occurring. And they did also test on the cohesion and the internal friction angle. And they did even a calculation with the percentage of quicklime, 1, 2, 3, 4, 5%, how the cohesion, let's say in this case, it is the internal friction angle is growing from almost from 15 to more something that is 30, which is 35. Okay, here it goes to 40, but at 6%. In real life, people are putting more 3% or 2%. So the earlier value I gave to you about Belgium with 30, was it again 31, is in line with what they discovered in their lab, totally different. Okay, so they find out the same, and on the cohesion they come always back to the to some similar, let's say, levels in this is in kilopascal. So they do also let's say those type of measurements, and in function of, let's say, this is for them the CBR value of their reference. For example, a reference aggregate, it's 77, and that is their reference for a 7.32 aggregate. And then they do, after 7 days, 10 plus 4 days in the water, 28 days, then they measure in function of the quantity of lime added to the system, okay, in the function of different soils, okay, then they measure and they see where is, first of all, not only the CDR, but also which is my EV2 value, okay, and this is typically values that they need to take into account, but you come to always such kind of figures. So on top of that, they went a bit further. They try to simulate in function of the speed of the train, so that's the velocity, so 40 km/h till that speed, but in real life they are working this way. So the static mobilis EV2 or dynamic should be about those levels that they, let's say, would like to achieve, and also CBR 40 means that you have one by formulas and let's say by learning from soils on place, they find those values. So correct values in which you can say, I can build on that. There is some topic I would like to raise, which is also for me important, because when we speak about clay soils, clay is not clay. Clay is something. Clay is one of those elements. This is a swelling. Sorry. This is about swelling. So swelling, when you put lime, we said always lime is reducing the swelling effect of the soil. Look a bit to what soils are can with. So when you have a not stabilized soil, 12.4, in terms of the lime quantity, so people are looking to values which are close below the value that they are looking at. 3 is in most cases acceptable. 0.4 is already very, very low for something that starts after 12.5. And this is a shrinking water potential that you have momentum. So it can also be measured by sorry. So when you look about, let's say, clays is also always a family of products. In clays, we have to understand, always to understand that maybe it's here it is a bit different because I will be honest, you are in a tropical area, and also for me it will be the first time that I see tropical soils, that I meet laterite. You don't find laterite in a lot of Europe. That's not principal, so it's not present in that area. So we have to see a bit and how the clays, and that is something of our interest because behind sorted and with lime, it is the reaction with clay, but what type of clay do we have, and so on. So this is something that we still a bit want to go, let's say, to find out on a better way, because we know that some of the clays or some of the, let's say, when you speak elite or kaolinite is one, the most, let's say, common that we face, but some are reacting more to the better to the quicklime compared to the other ones. So let's say locally available, and that is something, that from my point of view, we will have now to analyze a bit better, because once you know that part, you know also how it reacts. Then, just a picture, let's say, from those Hungarian highways, railways, where you see then how always it looks. You still see a bit of white spots from where the line is in open construction. The fastest high-speed railway that can be built on the soil is the one that is today under construction on the high-speed line between London and Birmingham. So when the French people were speaking about a line of 320 kilometers operating speed, they would like to go to 260, the absolute maximum of a soil can accept. If you go higher, you should build it on concrete. Okay, the impact of the dynamic loads are too important to anticipate with soil with line. Okay, we cannot go higher. So that project is today ongoing. It's the largest, let's say, investment of the United Kingdom. It's a project close to 35 or something like that billion euros, which is spent in a period of, I would say, 5 years. So they are really working now really on the full distance between Birmingham and then going to, which is the second most important city after London, to main line. And there's a lot of research done by the University of Nottingham, but okay, you have to look always to each professor, and there the professor is Paul Beaton. So always one of the guys who is also helping a lot, let's say, in the line business to do research and what he did. And we will also share with you, let's say, one of his papers, the publication on CT. So those were 5 projects. I just tell you where are we now today working on railways and high-speed railways as my company today as high-speed railway, because we're always proud to be in that game. Number 1 is in Italy. We are not, the name is not Carmeuse, not Golden Line neither, but there we use the name ViaCaCO. And in Turkey we use also the name Kimtaş. Also again, we are not Carmeuse, but it's 100% part of the Carmeuse. Okay. One is here between Istanbul and on the European part, to link Istanbul with Europe, because that's the goal. And the other one is typically to extend, let's say, the south of Italy, where high-speed railway is still missing in that part. So next year we will have the lines here between Palermo and Catania. Probably, let's say, that will be in the construction. They will start. If we look to this concept, and we said always we speak about costs, I think you should have already understood if you work with local soils, you don't have to need by the aggregate. So no problem with resources, no problem with your limestone quarries, no problem with production there. You can do it in remote zones when you are on the line between, I would say, imagine you have to do the line between Bangkok and Chiang Mai, because I already took the train. A lot of times you are driving, let's say, is going into woods, or let's say, how we call it there. So how do you get your aggregate there? So it will be much easier if you do, let's say, those sorts of lines, if you need to upscale them or to want to increase the speed or what else, by using it the local source. If we make a calculation, this is on Thai baht, okay, per cubic meter for, okay, that is with aggregates, how much it costs? It costs you roughly 650 Thai baht per cubic meter to put an aggregate in place. And to remove it, to landfill it, to buy the aggregate, to ship it to the building site, and so on. Based on normal transportation cost and the distance, you have that cost, 650 baht. That's the cost for the contract, for the investment. If you do it by, and it's already 2% of lime, which is, I would say, most of the projects in Europe are in that spectrum, or even some of them are even below that one. You are at 432 because you buy 2% of lime. With density of 1.8, was already higher. Today you are at so roughly 120 for the product which is supplied, delivered to the site. So the aggregates are very cheap, because cheap aggregates for this country means very cheap. In Europe is much more expensive, And so in Europe the price is roughly 600 baht per ton export. Okay, but then here the cost is always about the shipping cost, fuel. You have to pay the salaries. So for per ton, this is typically a cost that we know, because this is the cost that we know from our customers, as we also sell aggregates. So you see, saving 22%. Quite important for agencies, investors, you can name it, to make a lot of money. So how much did we treat, or what is our yearly experience in soil treatment? Figures, that is per year, okay? So the quantity of treated soil, we are more than 30 million cubic meters per year. This year we will probably reach close to 40 million cubic meters per year. And then you have to calculate the double. So how much do you save? 60 million per year. So that you don't need to buy, that are still in there, and that you don't need to use, okay? And that you can use, let's say, on a longer way. So I did in 1 hour roughly a study, or let's say not a study, a presentation on the aspects, experiences. So what did we say? You have this kind of situation when you have, let's say, bed or 4 rated, let's say, soils. You see the difficulty, not easy. So with that fine soils, you can mix it up with 1% of lime or 2%, so very low quantities, and you reach immediately, let's say, a surface which you can drive immediately with a truck. I speak about immediately, that means the day after. So if you treat it today, you compact it, and you can use it immediately the day after. So on the building site, you can save a lot of time, contract it, and save a lot of money. So we speak always about plastic soils, and makes it so a lot of building sites very difficult to manage during always a certain period of the day. That's always the things that I said I've bit or summarized with on the European way of methods. To be honest, it's true. You're working quite a lot with ISTM standards, so that is something we will try also to communicate later on. So we will try to work out a booklet which is more a code of good practice, but from Thailand, and that could be, I think, very good for you, that you can have that type of, let's say, work, and so that you can work on. And as a conclusion, I think those are really, let's say, the topics that we do, the advantages of soil treatment. What is it? So you see, it's earthquake resistant, okay, it's sustainable proof, because you are resource efficient, you reduce the cost, and you reduce the construction time. Those machines, they have high pace. It goes to 8 to 10,000 cubic meters in 24 hours. One machine. If you put 2, 3, or 4 machines, it's massive. It's a massive amount. It goes fast. That's the way. It's the only way it can go fast. So you save so much. No landfilling, no transportation cost, or much more limited, and you can dry up immediately, accessible for trucks. So the things, and it's also easy to control. So why shouldn't you use it? Yeah, put it. this sound, but I'm not sure you hear it.
We are interconnected world in perpetual motion. Highways, railways, ports and airports have become strategic and essential vectors for the economic, social and cultural development. However, building the critical infrastructure is often a challenge. To meet these needs, carmers offer solutions for recycling and improving the soils. ViaCaCO, the solution for fine soil treatment. ViaCaCO is ideal for quick improvement of the soil quality and for its long-term stabilization. ViaCaCO allows an easy economical and ecological performance. ViaCaCO family products allows us to offer a customized solution tailored to the type of soils in place. Soils treated with ViaCaCO could be used for making embankments and subgrades. This avoids costly operations and substitution. Improved soil compaction allows immediate movement of worksite engines. In addition, the maximum dry density increases while the optimum water content increases. ViaCaCO permits phenomena of soil drying and flocculation by interaction with the clay fractions. This results in a reduction of plasticity. Proctor test allows us to view the extent in which the implementation of ViaCaCO has reduced soil density. In the longer term, ViaCaCO also offers a solution for soil stabilization, improving CBR features to avoid the bad effects of water in plastic soils, like swelling and freeze or thaw incidents. The ViaCaCO solutions allow you to manage your work sites better thanks to a shorter period and a financial gain while being environmentally friendly and sustainable.
Okay, so that's it. Questions?
From your slide, you have field tests in a lot of countries. Do you have field tests in Thailand?
We are working on the first cases from our side, let's say in Thailand, that we are aware of. We know there were some cases in the past, but it was sold also. You can also use hydrated lime, and people were sometimes using a hydrated lime, but it was not successful because hydrate is not the right product for. We don't sell normally zero hydrate, but it was used in the past. You know, some literature was existing, and the Golden Lime company before it was even so many years ago, before it became Carmeuse, was shipped a bit of a big bag somewhere. But normally we don't use big bags, it's always in silo trucks that we are selling the product. And it was used, but it was not a lot of existence here. Not a lot of at this moment, not yet. No. No. That's why we are here now. Now we started to work with the roughly, I would say, we have an engineer, soil staff engineer here, the name is Adisak. So he will be the person to contact, so he's there in the back. So he's local, he's located in Bangkok, but okay, he's representing the Golden Line. He has, he's a site engineer officially, but okay, he's now trained more and more in that field because we didn't find anybody. There was nothing about lime treatment in Thailand today, or that must have been on a casual spot that we are even not aware of.
Maybe the follow-up question is this: when you say the effectiveness of quick lime will be far better in terms of treating the soil, why not hydrated lime? What are the differences?
Yeah, the difference is you do not have this temperature, let's say, increase, those exothermic reactions. That is one of the reasons that we feel that the formulation is not happening on the same way. You will see it immediately. It's not really formulating on the same way. And normally you use, let's say, already the soil to dry, let's say the lime, the quick lime to dry it out. The fact that you absorb already the lime plus the heating, you dry it faster out. So why are you transporting water to the building site? Because you need calcium oxide. That's the element you need. So it's a bit waste of shipping water to the building site. If you ship hydrated lime, so it's just increasing the cost of it. But the experience so I faced also in one country in Europe where there was no milled quick lime available. It was also it was in Bosnia and Herzegovina, again one of those communist countries. They didn't know in 2010 what to do. They have heard about the lime. Okay, they bought hydrated lime. They put it for a highway and it failed completely. And it was then for them a foreign contractor from it was a time already from Italy, but the Italian contractor bought hydrated lime. He said, look, it will work as well, and it did not work. So that is one negative. Let's say one case I knew, and it was immediately negative. So don't use hydrate. So that's my opinion. It will be extremely exceptional to use the hydrated lime, and I can think when the soil must be extremely, let's say, extremely dry already, that you don't want to dry it more. But then you should come in levels that I don't face. So maybe here, I'm not sure. You are even good temperature, but the moisture in the soil is still at the correct level, and you are more, I think, in cohesive soils you are easily more than 10%. So,
From my understanding, I'm not sure.
you don't need to look to the top surface, you look to 1 meter, 2 meter, 3 meter, because that's the one you excavate, so in general. So I do not expect that we will for hydrated lime not here either. In North America it's zero, although we supply also to the states like Florida, where we have similar temperatures like here.
Okay, basically just to recap, the reason I'm asking the question is, if you hydrated lime or the quick lime, the main advantage at the beginning of the quick lime is it produces heat. When you mix it, produce heat. So in a way, it can dry up your soil a lot quicker. So when we have a wet material, like the example Mr. Christo was showing earlier, one section of the road, was very wet. But the moment you add the lime, and then in fact, then you get a quick dry.
This is just on the pass, what you see there is just 30 centimeters thick and compact, that's it. And that area that you see there took just a couple of hours. So it's immediately that you have this kind of, let's say, from that, and that was immediate. That was the picture, I would say, the day before, because you have a bit of sunshine, and then they started in the morning, and it was then the day after. So that's it. It's very simple. And with such kind of values that we can achieve, in a lot of ways it is easy to make service roads, so that trucks can already go to the right spot, or service roads or parts of service roads will become later on part of the embankment. So it depends a bit how your service road will be built, let's say later on what you use with that material. But it's extremely cheap material, let's say solution, not material, but solution to make such kind of things and to facilitate your work site. And when you think about railways or a big project where you need massive materials or you are far away from quarries, think about all the shipments that you need to pay and to do. And it would be, I think, better to initiate the soil recycling or the soil reuse in place that you have. You save a lot of aspects.
Sir,
Yeah.
what are the common type of failures observed in the lime-treated soil?
I'm sorry?
The common type of failures that occur in the lime-treated soil. The type of failures it could occur in the lime-treated soil.
Maybe at this moment, we are trying to find one. If I look to soil, let's say soil with cement, for example, soil cement makes a structure rigid. Okay, what is happening? We can have a very rigid structure. It will, due to dynamic loads and loads that you will have, you will create cracks. Okay? Typical cracks like in concrete. What is happening then, it goes and they will create pump effects from moisture coming in your system, and you go, and then it even blows up, the system on top. So we don't have that, but we have also cracks. But what we have in our system is micro cracks, much smaller, because lime is much smaller compared to a cement grain. It's a factor 1 to 10, 1 to 100. So it's much smaller, and that makes that system, when you have a good, let's say, a traditional good mixed, let's say, soil treated layer, there will come some microcracking because, okay, load is there. So, okay, but due to this high pH that remains in the soil, there is still enough silica and aluminum available for the quicklime which is still there in your system. So at this moment, we started to work on a publication for long-term durability on proven tracks for European, let's say, projects that we did so many years ago. And I will be honest, let's say, the first country where most of the, let's say, the information was gathered was France. Remember, the first railway was high-speed railway, was also France. So we can go back to sites of more than 50 years now, in which we let's say, took some samples and drillings from 10 to 50 meters. I speak about those kind of drillings because it was thick layers where we are now, let's say, measuring, measuring, let's say, all the aspects. The measurements are done, the paper is done, it is submitted to a conference, and it will be in April in France, expressed by because everything is paid by the French Association of Earthquake Contractors, which is a good organization. They have a good know-how, very professional companies, large size. They have a soil lab, fantastic soil labs. They know extremely well these kind of methodologies. So the companies behind are the Vinci Group, Collas Group, Gui Group, Eiffage Groups. So those type of companies are really behind a lot of know-how, and local universities as well, research centers for local research. And if you ask me, let's say the feature is negative. The one feature which was negative and that created troubles, that's maybe a good one, was the story of Italy. So the Italians started to say, okay, lime treatment is good and we saw it from Americas. I would like to use it, and they did it. It was in the beginning of 1980. And so 45 years ago. And what they did, the company that was doing it was located in the Venice area. Venice, London city, or historical city. So nothing to do about the city itself, but just the area. The only thing that they overlooked was to measure the sulfate and the sulfate content in the soil. Unfortunately, there were quite high amounts of sulfate in those areas, natural way present in the soil. They built on top that soil, they used that soil with the lime and say compacting everything is good and you can build a road, and in less than 1 year they had to improve everything. They overlooked the sulfate. So that's the reason in the beginning I want to make sure that we will measure a bit in all the areas sulfate content to make sure that there is no grains of areas of gypsum. So for example, I showed you the London place from London to Birmingham. Yes, they are quite high in sulfate. Okay, and even without that problem, we treat them with lime. Okay, because then you do a bit of double treatment. First, you do the treatment with the quicklime, so you create with the mixed with the soil, you create the etangite formation, and the next day you do a next double treatment because then the etangite is killed. This is already there, and that's a bit how it works. So okay, when the sulfate is too high, it's sky high, no, then we don't do it anymore. There are some limitations. I think, what was it again? I think it is 3,000 ppm of sulfate that you will have, something like that. So you do some tests, you measure, and I think it was 3,000 ppm. But
Again, follow-up question, a couple of things. Any environmental or negative sign, environmental impact if we use the lime, like for example vegetation, groundwater?
yeah.
Any change like in the pH?
Yes,
of the
that's also one remark. Can I use it?
Yeah, sure.
So when you have so your treated layer, so you have soil was now, okay? So your pH, as you said, is more than 12.4. What we discovered is lime can be fantastically good if you will do some leaching test. Leaching test, okay? And you measure from a sample in that part how it's leaching. We discovered that sometimes we found that we have too much copper and zinc that was leaching. And we said to ourselves, what's this? What's happening? Now, the copper and zinc was present in the soil. It was in the soil. The pH makes that it starts to move. But once you come just below that area, okay, and you must have maximum, let's say, this is really absolute maximum 10 centimeter. You are coming back to the pH of the natural soil. 6, 7, or something like this. Anyhow, the elements, copper or zinc, that are in the move will stop. And then there is no more leaching anymore from here, no pollution. Okay, so there's no pollution. You have to take into account that below the layer, due to the pH which is there 12, here you go, then yeah, the pH is going down to normal level. If I can call it like this, normal level when you start. And that is just 10 centimeter, let's say that way. And there you have to, and here you can find back sometimes the elements that are in the soil due to the high pH. That is true, that is what we can find. And that's the only one. But what we do is here you transport a bit the pollutant and the heavy metal that is present in the soil, but you ship it to somewhere else. You don't, it can only be transported once. So, okay, so there's no pollution for this type of exercise. On the principle, I would say, that is not. And lime, by definition, does not contain pollutant elements because we have to burn our stone, let's say, very well selective in the mine. We use, let's say, we cannot burn waste materials like cement industry because otherwise it sticks to the lime in the process. So we have to use natural gas or, let's say, clean ways of burning in the process to make sure that we don't pollute the lime ourselves, because the lime, which is a bit, let's say, with a bit too much sulfate or from you can name it from coal combustion or something like that, is not appreciated in our applications. So then we have a problem with the customer.
Well, just a couple of questions from the very beginning. The line, the quick line that you produce, what is the product like once it's out of the plant?
So
is it in a powder form or granular form?
So we go in the stone that we are putting in the kiln is 50 to 120 roughly. Yeah? That is it depends a bit on some kilns. So kiln 1, okay, I will be kiln 1. We will use this to this type. In another one, kiln 2, okay, we will go from 20 to 50. Okay, because we see that is then the size of the size of stone is 20 to 50. There it is 50 to 120. When it comes out of the kiln, it has plus minus the same size. Same size. The CO2 goes out and it becomes less dense compared to the initial product. The CO2 goes really out as on that picture.
I'm sorry, the 50 to 120, what is
Millimeter.
the unit?
Millimeter.
Oh, millimeter.
Sorry.
Okay.
So here on this the diagram in the beginning, so if you see that stone size, it's exactly the same as that size. It's really that one, and the CO2 goes really, it keeps its form almost, and really the CO2 goes stepwise out. So when we have too much unburned particles, you see them, for example, this one, the inner part is not yet fully decarbonated. Yeah, clients start to call us because for them this is not usable. You see, they like calcium oxide, they don't like calcium carbonate in the process. So they don't like it. So it needs to be minimized, and we have always six steps at minimum. It must be less than 1% or 1.5% or 2%, depending a bit on the application. So, and that's also the reason why you do a kiln with a certain type of stone. Otherwise, if you put too much from 0 to 120, the very small stone will be overburnt, while the big part will be not yet fully decarbonized. So we need to put in close sizes. Sometimes it's 50 to 120. I know in another factory we do only 90 to 120, so that's only one factory. But mostly it's something like 50 or 60 to 120. So similar size all the time.
Basically, from the next thing is from the plant, let's say to the site. In terms of storage, is there any special storage precaution that we need to have?
For
how long we can store it for?
Yeah, for the quicklime, which is typically supplied to the, let's say to the building site, there is 0 to 3 millimeter. That is because when it is also finer, it becomes too dusty on the building site. Remember, there was a question for hydrate in the beginning. Hydrated lime is very fine. Also, that creates a lot of troubles because wind is blowing it up too much, and it's also creating, let's say, when you have ice, let's say lime in your eyes, it's like cement, it burns. To be honest, when you have quicklime, it burns even harder, but quicklime is not so fine compared to the hydrated lime. So this type of product, let's say the fine material, is always stored in a silo, in our big silos, and we supply it always by a big truck. Maybe I have one movie more that I could show the principle how it goes on real building site. It's on a highway. It's also a movie. 3 minutes, and I will explain what is there on the drawing. I hope it works.
Where is he from? What is meaning of this signal? No, really? I don't know.
It's not there. Yeah, I think it's with the settings that it's set my screen.
สายมันหลวมมากขยับสาย
I think it's based on my settings when it's setting my PC. I think it's a my PC. I have to change my settings, my screen.
Yes, yes, yes.
Otherwise, I have to turn my PC. But then people have to go around it.
What you do, you use your phone, and then you watch it from your phone.
Yeah.
Okay, that's fine.
Yeah. So do it from here.
Feedback with the secret. Can you just move the cursor from beginning?
The beginning is a C same movie as you have seen.
Oh,
So
okay.
that is, but now it starts from the side,
Yeah.
from an hand here. So,
Oh, that's good. That's good.
so we do this. You see, the place of excavation. Okay, that's the excavation zone. And of course, our really, let's say, come. So that's the excavation zone where we excavate the earth. That's not just a typical high layer. So and then it goes to the building site, or let's say, it is already a building site, but step by step, the bricks are built, let's say, putting the product at the right place for the. I mean, this is already a treated layer. We are driving on a treated layer.
So it come in powder form.
We come in powder form. Yes. Here you see it. So here you see the truck.
The truck side.
Yeah, yes. And we load this small loaders all the time. And the truck stays 2-3 hours on the building site because the loader is too small. And then it goes spreading. This is again the mixing, the mixing that is ongoing. And you see a bit of speed, but this is, I said, to roughly 8 to 10,000 square meters a day. So. So we recycle, of course, that's the ideal thing. And I think that is, yeah, I think was the same as the. But you have seen a bit along the main topic, and so you take it and then you ship it on the building side, and that is it.
So the process wise, you have so the process wise you have first of all spreading, right, mixing, right, then before we what we call grading, leveling, and so on. Do you add water during after spreading the line? No water.
Only eventually before the spread. So it is sometimes we are adding this, you saw there water tank on the pictures. That is sometimes before to have water on the side itself, and there on top we spread, let's say, it's only at that moment that we do that.
If needed, then you may spray the water after spreading, or after mixing.
Before the spread.
Before the spreading.
Before spreading the water.
Okay.
Then the water is already there. It is more on the surface, maybe, let's say maybe the top surface that you do then this exercise. They do it also to sometimes avoid the dust when you are in an industrial area. You are close to, yeah, you try to avoid also some dust issues.
Okay.
So it's not only for the water to come on the soil.
Okay.
But it's not that often used. Let's say, yes, it's often done, but it's not every time needed. So they measure every morning the moisture content of the soils that they get, so that they have a good idea if yes or no they need it. So it's a bit always a constant. And then they see always because you have a building site which is, for example, on the road, let's say a corridor. Anyhow, the soil will change a lot. It's a stepwise. When you have a big area, an industrial park, the soil will not change. Two, 3 types of soil, maximum 3, I would say. You identify this type of soil, A, B, C, and that is enough. So, if you have already 3, most of the normal size of 10,000 cubic square meters, cubic meters, or it should change a lot. Let's say it depends on the depth that you go, but most of the time.
Okay.
But in the roads construction, you changes because you, so it's like sometimes are changing depending on the skating event and everything.
So what you're saying, you will spread some water, maybe for dust control at the beginning.
Dust control.
Yeah. And then I guess later on, probably after mixing, so on, you need to have some moisture, right, to get a certain total compaction.
Yeah. In case there would not be enough, let's say then we have to put the water later on. Exactly. But before the mixing, always before the mixing. Always before the mixing. I'm always curious about this landscape. Again, you are closer to the equator. What will be the impact on the high temperatures, on the soil conditions that you have in place or that you take? Will it change that it will be so dry? At this moment, I have not a feeling that out of some first results that we have now, that was the initial. It's too early. More questions?
One question each.
Maybe I missed the spot in the presentation. I think what's the best or the sweet spot of like direction of combination of the lime to the soil? Because I'm afraid it might be too much, it might be brittle at some points.
No, we don't have brittleness like cement. That is a problem that we don't have. We don't have shrinkage like cement. It will just dry out. It will be a bit stronger. If you put from 1% to 2%, you will see it will be just become a bit stronger after a certain amount of time. But we are speaking about strongness. We saw there a value after 7 days, 0.7, that we were only reaching already 1 point and so on. Okay. Normally we go to those kind of levels. It will not be, brittleness is not one of us. It's don't help because we are so used for this, let's say, dynamic loads that the system is always anticipating with is flexible. I will not call it elastic because that's not true. That's not the wrong word, but it is, let's say, semi-rigid or different behavior compared to cement. I know from the cement industry, shrinkage is not sure because we know that behavior. We are dynamic reactions. We are making micro structural processes like items. They're not the same. They're not all the same distance of meters compared to cement, which you, in case due to dynamic loads, you break and it is down. Because we look at the place to move.
Whatever issue is mine.
Yeah. On the
So just again recap. So what you're saying, the application will be about usually it's about 1 to 2% by weight.
by weight,
By weight.
so yes,
By
by the
weight. That's
density,
the scale
by density of the load.
So if you have a cubic meter, right, that means it will be about maybe, instead of 1 to 2, then it will be about 2 to 4% by volume or weight of, let's say you have a 2% by weight, then this case will be around 4% by, say, cubic meter of water.
Imagine you have this type of soil. So let's see, if we think
So
about
you
2%.
So 36 kilogram, say, per cubic meter.
Today, we are supplying a very large site. For example, a very large site in Turkey, a highway construction is highway. To give you an idea,
Oh, what? Oh, okay. 1,200 ton. Okay.
not us,
But
but
they,
it gives you an idea from 36 to what we supply to a building site. So then you can start to calculate. Because
divided
there
by
they are,
36, then there will be a cubic
and
meter.
they are putting 3% because they want to stabilize them very fast. So when you go to a higher quantity, it is just to speed it up. Okay, but it's not always needed. For me, 3% is also the highest that I see for reasons, but it's always to speed up things. But it gives you an idea of what we do, and then you can calculate the number of cubic meters. Then can be a bit impressed. That's the biggest that we have. Bigger than that, we cannot supply either because in a certain area there is not so much time available.
difference?
Yeah.
What if we come across with sandy, like if we say clay sand, can we apply the same?
Yeah. Once you will come,
Yeah, maybe change the question a little bit. So the application part, I think you mentioned about there's a certain limit of the PI. That's one thing. Then what about the gradation, grain size? Whether there's a range, of say particle size that might be suitable.
yeah. So every time we come back to the same, let's say the same table
Yeah.
to say, okay, if it's suitable, yes or no, and then you speak about whatever type of sandy gravel, clay containing or else. Let's classify it according to this way. You have here the ashton, but the ashton is part of the solution of the soil or the material you have. On top you have the limit plasticity index to measure also that plasticity index. And then you see a bit, okay, so where are we good? When you will find clay gravel or clay sand or silty soils or silty clay soils. Yeah, the clay soils for sure. You speak about clay for sure. But all that area is suitable for this type of material. If you go in a very strong, let's say performance for 2 megapascal, or you can name it, let's say with this type of materials, A1 and A3, use cement. Use cement in this case. So in Europe we don't use cement anymore even for that one, because cement is already out. It is more a combination of slags and fly ashes that they find. You see, it's a bit more hydraulic materials, but not clinker. Because the clinker is the most negative part in the soil.
So just recap a few things. So one, you mentioned about the PI. So what sort of minimum PI that we? Minimum PI will be 5. Okay, there. Minimum PI 5. Then in terms of grain size, let's say fine contents, no issue. Basically, you can range all the way.
It's no size. The problem becomes when it is too stony material, that the soil mixing machine will have to handle with those big stones. So in areas when you find, let's say, fine materials, fine material with stone material mixed by nature or by due to some circumstances, they do by a plug. So you could remove, let's say, the biggest stones because you destroy a bit, let's say, the soil mixers. Now those soil mixers that you have here today, they have the quality from the asphalt recycling. And now, very honest to you, asphalt recycling is already a strong material. So they have the best quality of those, because it's full of teeth, there's this kind of mixing unit. So, and because they break all the time. Okay, every X day they need to replace so many. So it's, for them, one of the biggest costs as well. But with this way, it's just to prevent too much maintenance.
Actually, another factor is this: the moisture content of the soil, right? Usually, what kind of moisture content you work with? Well, for this particular table wise, it's just
for this particular table wise. In general, we are working as a maximum 20 to 30, close to 30. That is for me typically a maximum. Otherwise, it becomes too wetty. People will put then more lime because everything counts, but then you need the lime to dry it up first. You see what I mean? The first particles will just be drying it out. And then you will go to, in some exceptional cases when it is extremely wet, to 4%, which is true. That is not for geotechnic purposes, but just for drying out because it's too wet that you have locally available. That is the topic that we find out here. When you speak about your soft clays from Bangkok, that's
actually
another question.
That's right. The range why we are looking, if you are dealing with soft clay, which is the deposit, or deposit, then it's the lowest, right? Typically lowest something like about 80, but all the way 114%.
Yeah. There is something I would like, let's say, to learn a bit now more about the Bangkok clays, and yes, we are looking to to understand, let's say, with a partner in the university to study it first and then to see what is really good. And if you're the right person here, we are open to collaborate. So, yeah. Because you said already that there is some experience probably, because to be honest, it's not a new product either. And it's not like we invented an iPhone, you know, like 1 years ago. No, it's really let's say a common product. There is already some common understanding also in geotechnical online in place. But how it works and performs, and if in case your soft place, I don't know. So I work with the soft, let's say soft soils from Scandinavia, where they have a lot of, let's say, organic clay-containing soils, peat. They call it local peat. And so it's very, it's a soil in which you can almost not run. So, and there they are analyzing it, and they are also putting binders, but they use more a methodology in that case, which is mass stabilization. It's also it's a Finnish method, and the machinery providers are from locally. It's Ramboll let's say, Ramboll is an engineering company, but they have also special those soil labs, and they know those methodologies for the soft soils, because they develop the test by themselves, and they are the only one who do it. And the soils are. Finland is just a swamp. Finland is just a swamp. You cannot build high-rise in Finland. It's impossible. You are in the middle of a swamp there. So the highest tallest buildings are there, I think 10 floors or something like this, that you can build. Otherwise it's not possible. And there they develop a method of mass stabilization. In that case they use also lime. Lime is part of lime cement. Lime cement. Because the lime is needed for the clay which is in the peat. Because it's 50-50. 50% clay, 50% organic materials. Once the material peat becomes 100% organic, I have no place, huh? It's cement. It's cement, it's not for us anymore. But the soft soils that I have seen from Bangkok, you cannot measure. For me, they are too hard compared to the soft soils we speak about Scandinavia. Scandinavia is like a liquid, huh? It behaves like a liquid. You cannot go on it by foot. I think on Bangkok place we can still walk on Bangkok place. Am I sinking when I go on a Bangkok place?
Depending on your weight. Before dinner, after.
Okay. But I faced already the problem, so that's the reason why I know it. And I was in the. It's strange, yeah, it's a very strange environment. So
just to add on what you said about the finish, you know, as far as we understand, I think in fact, the Thailand also using what we call the deep mixing with lime.
Yeah, it's deep mixing.
And that was introduced to Thailand in the 90s.
Yeah.
90s, they even brought in some.
I think that you speak about land columns. Yeah. So as they have soft soils, as they have clay containing, let's say organic or clay materials, so they work quite often in lime again to make the flocculation, to neutralize the bad effects of the clay, to make something granular that you can use. And that was the reason why they did it. But when you see it on world scale, lime columns were often easily replaced by cement columns, because with cement it's easier to get access to. In the practice, when you start to do this kind of big jobs, you need to have not only lime capacity but also milling capacity, because it's always milled lime, so it needs to be crushed. Okay, so we are always looking to have that capacity, and that capacity was not always existing enough to supply the market, and that killed a bit the lime columns, say, concept. But yeah, when you start really to make a lot of lime piles or piling, you need a lot of binder, so it goes fast also. So this is our biggest project. Okay, that we don't. It's only one project, maybe on top of that also much other projects, but it's only one. So can go up to very high amounts.
Could you also explain the influence gap for one geometry here.
Yeah.
Having the surface facing on the accuracy, the influence that
So, to come back to your question, so the influence of soil treatment layer compared to
surface facing and deep facing.
and deep mixing. Let's say when you speak about the deep mixing, is it the one, the mass stabilization that I speak about or not? Because when I speak about the mass stabilization in Finland, so you see the structure is a road, you have the, let's say, asphalt, okay, to make it like a road, asphalt, you have the base, okay, you have the subgrade, no, the subbase, subbase. There you have then what we call the subgrade. Okay. And what the Finnish people doing, let's say, for mass stabilization of what I call the deep mixing that they can reach, it's only maximum 8 meters thick, they produce something on a liquid area, on a swell, something which is, I will call it the base for subgrade. Okay? Base for subgrade. If you will measure a compressive strength, and this is all the time something, it depends a bit on how the thickness of the peat layers. Sometimes it is 3 meters, in some areas 5, some 8. So, okay, it depends a bit on the topic. So let's say it is 5 meters, let's say the area. So they prepare a base for subbase. If you do, because they produce not proctus, they produce something similar, okay? And the compressive strength that they are looking for is 100, sometimes it's about 100 kilopascals. So 100, 0.1 megapascal. Okay? So they are looking to those low values. And if they see that you can reach by this treatment, let's say, that area, and it is always of the whole surface. So, okay, and I can show a picture how it looks like a machine because that can be maybe of interest. And that is really the base of that one. And then you can say, now I have a subgrade on which I can start to work. Eventually, I treat my subgrade only once to have something already better. And then you can say, now I can go to my real subgrade. And that's the way they work, because they work on, they start always from something which is very liquid. And the quantity of the binder in that one, remember I said here, 36 kilograms. Okay, in those cases, it's 150 kilograms per cubic meter. It's almost in that area that you have to look. Okay, so it's much more expensive, but you need very soft soils, and I will show a machine. The PowerPoint is working. When I see the screen, so I can fit.